and welcome back to our lessons. And in this lesson we are going to look at some more rules when we are talking about rearranging objects. Now in our previous lesson we used all the different objects, okay? For example, in the word sand we used all the different letters and rearranged them to form groups, okay? And those groups were all the new words that we could form. Each group consisted of all the objects. In other words, each of the words that we had to make had all the letters of the word sand, right? Now in this lesson, we will only use a certain amount of objects. So if we had a word, for example, sand, we will only use maybe 2 of the letters to make new groups. And then we want to see how many different groups can we make without using all the letters, for example, of a word. Now here is an example. We take 6 books, A, B, C, D, E, and F, and rearrange them on a shelf. Okay, so we take these 6 books and we arrange them on a shelf. Nothing new, we've done this before. How many different combinations are there? And do you remember what we do? If we want to rearrange things in a row, we simply count how many things we want to rearrange, which will be 6, and then we will use the factorial, which means 6 times 5 times 4 times 3 times 2 times 1, right? So basically we will have the 6, and you can do that on your calculator and it will end up to be 720. Okay, so this answer is 720 different ways we can rearrange 6 books. Now, look at this example. We take these same 6 books, okay, A, B, C, D, E, and F, and rearrange them in groups consisting of only 2 books. So here we used all 6 books and we rearranged them on a shelf, and that's how many possibilities. Now we just want to use 2 books at a time. For example, A, B, or B and E, and C and D, and see how many different combinations of 2 we can get, okay? So we take these same 6 books and rearrange them in groups consisting of only 2 books. How many different groups of 2 are possible? Now, if we have an example like this, we will use the following formula, where we will say that m factorial is the total number of possibilities, okay? And then again we will say it's m, which is the total number of possibilities, but without the factorial sign, minus the number of items chosen in a group. So how many items are chosen in a group? 2 books, right? So we've got 1, 2, 3, 4, 5, 6 books, which will be m minus 2, that's 4, and then we use the factorial sign. Okay, but this is so important to remember. We will use this rule number 3 when no repeating of items are allowed, or when we cannot repeat items. Now let me show you why we cannot repeat items. Sometimes we are lucky that they tell us that we cannot repeat items. Other times we have to use our common sense. So let me quickly show you what I mean. So we want to make groups of 2 by taking 2 books and putting them together. So again, let's say we use book A and we group it with book B, okay? And then I take book C and I group it with book D. So we cannot use book A again because I already used it with B. So the only 2 that's left is E and F. And that's what I mean that we cannot repeat any of these books. Okay, so there's different combinations as well. We can, for example, say A and D. We can say B and E. And then we can have C and F, for example. And each time, do you see when we group all 6 in groups of 2, there's no repetition of books. So there's no repeating of items. We use this formula. Now again, the total number of possibilities is all the total number of books that we have, or all the different objects, which is 1, 2, 3, 4, 5, 6. So let's quickly do that here. So this will be 6 factorial divided by, and then we take all the different number of possibilities, which is m, which is 6, and see this time there's no factorial with it. We minus the number of items chosen in a group. Now, how many items are chosen in a group? 2, right? So 6 minus the 2, because it's 2 books in a group. That's the number of items in a group. We put this in brackets, and then we have the factorial. So this ends up to be 6 factorial divided by 4 factorial. And then we will finally see what is the total number of combinations when we take 6 books and we actually rearrange them in groups of 2. So there will be 30 different combinations that we can come up with, and I only wrote down 1, 2, 3, 4, 5, 6 in those. So there's 24 more different combinations to go. Okay, so I hope you got it, and then we will go over to rule number 4, which is pretty similar to this type of question, but here we will say that repetition is allowed. Okay, so please, again, there is a difference between the two. Okay, so in these examples below, the items may be repeated. If repeating is not allowed, we cannot use this method. We will simply use rule number 3. Okay, so here we go. When you have groups and each group also have a certain amount of items, we simply take the amount of items and raise it to the power of how many groups there are. Okay, so let's have a look at this example. There are 5 multiple choice questions, each having 4 possible answers. Okay, so there's 5 groups and each group has 4 possible answers. Okay, so how many possible ways are there of answering these questions if you simply guess the answers? Now again, let's use a bit of common sense. If you go to the first multiple choice question, you can choose between, for example, A, B, C, and D, right? Now, if you go to the second multiple choice question, you can choose A, B, C, or D again. So basically, answers can be repeated. And when answers are repeated or items are repeated, we cannot use rule number 3. We will use rule number 4. So this answer is quite easy. We take the amount of items. There's 4 items in each group. And then how many groups are there? 5, and that equals 2. And this is quite easy. 4 to the power of 5 is 1024. Okay, easy, right? So let's have a look at the next question. How many 3-digit numbers can be formed with the digits 0 to 9 if the numbers can be repeated? So this is actually 3 groups, because for the first digit we've got 10 choices. For the second digit we've got 10 choices. For the third digit we've got 10 choices, because numbers can be repeated. Okay, so how many 3-digit numbers can be formed with the digits 0 to 9? So we've got 3 groups with 10 choices. So what do? We write down our 10 choices, we raise it to the power of how many groups, and that is equal to 1,000. Okay, great. So do you see the difference between rule 4 and rule number 3? It's simply that in this rule number 3 we use this formula, and we can also write here at the front that M, which is on this side of the P, which means the amount of permutations, with the N there at the bottom. And you know what the M actually is. That's the total number of possibilities. Well, there were 6 books. We have the P, and N is the number of books in a group, which is 2. Okay, so you can put that at the front as well if you want to. Okay, now for rule number 3, let's get back to the point here that there's no repeating of items. In rule number 4, there are repeating of items. Now we're going to try a whole bunch of examples to revise all of these different counting methods and rules. Now let us revise all the different counting rules with examples. At the pasta place down the road, you can order 6 different types of pasta and 28 different sauces. How many different meals can be made? Okay, so this is the basic counting principle, because for our first choice, we've got 6 options of pasta. For the second choice, we've got 28 options of sauces. So we simply take the amount of options for our first choice, which is 6, times 28 options for our second choice, and then it's 6 times 28, which gives us 168 different meals. In how many different ways can 7 books be arranged on a shelf? That's easy. We want to arrange things in a row. So that's the factorial. So 7 factorial, and that equals to 5040. Okay, brilliant. So now, in how many different ways can 9 people sit at the front row of the concert? So we basically want to rearrange 9 people in a row. So that will be 9 factorial. That gives us 362,880. Now, next question. In how many ways can a 3-letter word be made from the letters C, D, E, and F without repeating a letter? Okay, so no repetition is allowed. This is our amount of groups because we've got a 3-letter word, so there's 3 groups. For the first letter, there's 4 items. For the second letter, there's 3 items. And for the last letter, there will be 2 items because without repeating a letter, we're not allowed to repeat, right? So we know that when we do not have repetition and we're not using all of these items, we're making groups, we can simply say the following, that the amount of permutations that we can have, there are 4 different items, we're making groups of 3, or there's 3 groups, that will simply be the 4 factorial divided by 4 minus 3 in brackets factorial, that is 4 factorial over 1 factorial equals, and that gives us 24. Another way to do this is by simply saying that for the first letter we've got 4 choices, so that will be 4, right? And I'm doing this on the side. And then for the second letter, there will be 3 letters left. So again, we multiply it with 3, basic counting principle. And then for our last letter, we will have 2 choices left. So multiplied by 2, and the answer will be 24. So it's the same as if we use the basic counting principle. Now, how many possible choices can be made in a multiple choice quiz if there are 4 questions with each 3 answers? So we've got 4 questions and each question has 3 answers. Now when we have a multiple choice question, for the first question I can choose, for example, an A. For the second question I can also choose A, so our answers or the items can be repeated. And that means we simply take rule number 4, which says that we take the amount of items, which is 3 items in each group. There's 4 multiple choice questions, so 4 groups, so raise it to the power of 4, and then we are basically done. So 3 to the power of 4 is 81. Okay, and that is it. So let's go and look at some more examples. Now in this question they say how many different words can be made using the letters from Limpopo. So we are going to rearrange these letters in a row, but some of these letters repeat themselves. Now you know what we do then. We take the n factorial, right? Can you remember this? Divided by r factorial. That was one of our rules. And then we can simply go and say that the total amount of letters we can rearrange is 1, 2, 3, 4, 5, 6, 7. So we will simply say 7 factorial. So therefore we can say 7 factorial divided by the letters that repeat themselves. And that is P and P, so 2 factorial times, and is there any other letters that repeat themselves? Yes, O and O, so again 2 factorial, and then we can simply work that out on the calculator by writing the 7 factorial, using the fraction button, writing 2 factorial times 2 factorial, and that equals to 1,260 different words that can be made by rearranging those letters. Now, how many 3-digit numbers can be made? Okay, 3-digit numbers can be made from the digits 1 to 5. Okay, so that means 1, 2, 3, 4, 5. It's 5 different items to make 3-digit numbers. And repetition are allowed. So when repetition are allowed, we will simply say that For the first letter, we've got 5 choices. For the second digit, we've got 5 choices. And for the last digit, we've got 5 choices. So we can basically just multiply those 3 digits. So let me show you if we use the basic counting principle. So for the first digit, because remember we're making a 3-digit number. So for the first digit, we've got 5 choices, 1 to 5. So that will be 5 times, and then for the second digit we've got 5 again, times 5 times, and for the last digit we've got 5 choices again. There we go, or 5 items. So basically that's where we come up with the 5 to the power of 3, because there's 5 items, there's 3 groups, 5 to the power of 3, and we all know that this is 125. Okay, so that's how easy it is. Now, what do we do if repetition are not allowed? Then we will simply say for the first digit there's 5 choices. For the second digit there is how many choices? 4. And for the third digit there will be 3 left, right? So that will basically be 5 times 4 times 3. That will be 60 different letters or digit numbers that, or 3-digit numbers that can be made. What we also can do is we can say the following. There are 5 different choices. There's 3 groups. So that means it will be 5 factorial divided by 5 minus 3, and then the factorial. That is 5 factorial divided by 2 factorial, and we will get 60 again. Okay, so please remember it's kind of the same as our normal counting method, which is quite easy. And then with our last question, we simply want to make a code by using the format XYY, where X is any letter in the alphabet and Y represents any digit from 0 to 9. So how many possible codes can be made if the letters and digits are repeated? So that represents the alphabet. There's 26 letters in the alphabet. So for our X, we've got 26 different options. And then for that Y, the first Y there, we've got 10 different digits because 0 is included. 0 to 9 is 10 digits. So times 10. And remember, we are allowed to repeat. And then for the last one, it's also digits or numbers. So there's also 10 of them. So multiplied by 10. And this equals to be 26 times 10 times 10. We basically just add 2 zeros, which is 2,600 different possible codes. Now, how many possible codes can be made if no repetition are allowed? We're not allowed to repeat digits. So again, for the X, there's 26 different alphabet letters. We multiply with 10 digits for the first Y, but now we chose 1 digit already. So for the second Y, there's only 9 digits, and this will equal to 2,340, and that's it. So I hope with these examples you could see how the basic counting principle is similar to our rule number 3 and 4. You just have to see the difference when repetition are allowed and when repetition are not allowed. Okay, great. So that's the end of our counting principles and rules, and hope to see you again soon. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.